So hi friends, this is your Prashant sir. Welcomes you to the world of physics from KH Patil PU College, Hubballi. So in last class we have started the chapter number 13, that is nuclei. I just given an introductory part to the chapter. In that introductory lecture, we have discussed what is meant by atomic nucleus and what are the composition of atomic nucleus, and about atomic nucleons we have discussed a little bit, right? So first of all, what is meant by atomic nucleus? So atomic nucleus is a central core of an atom where the entire mass of the atom is going to be concentrated with the net positive charge. This positive charge because of the presence of protons, and the neutrons are present in the nucleus but they are neutral, but because of that reason the charge of the charge of the nucleus is only due to the protons, and that is positive, that is always positive. So we have discussed this much, and next we have discussed some of the notes, that is what who discovered proton, what is the mass of a proton, what is the charge of proton, who discovered neutron, what is the charge of neutron, what is the mass of neutron, who discovered electron, and what is the mass of electron, what is the charge of electron, and who discovered the whole nucleus. All these things we have discussed in the last class. Please go through it. And next we have also discussed what is meant by atomic number and what is meant by atomic mass number. So atomic number is the number of protons present inside the nucleus, the number of protons present inside the nucleus, and it is always represented by capital Z. And atomic mass number is the number of protons and neutrons present inside the nucleus, and it is always represented by capital A, right? So up to this we have discussed. So in today's class we will go through some of the notes they are given here. The first note, that means we already know that atomic mass number will be represented by capital A. Atomic mass number will be represented by capital A, and it is the sum of protons and neutrons. And atomic number is represented by capital Z, and it is the number of protons only. That means it doesn't include the number of neutrons. So if we calculate the number of neutrons, then we have to subtract the atomic number from atomic mass number, that is nothing but A minus Z. A minus Z, that means to get a number of neutrons, the simple formula is A minus Z. That means we have to subtract the atomic number from atomic mass number. That will gives you the number of neutrons. And if you consider on second note here, the nucleus of an atom or the atom will be represented with atomic number and atomic mass number by the symbol XZA. Here it is. So it is, I will write again here, X. In subscript, one thing you must have to concentrate, that here X is in general atomic symbol, in general symbol of an atom. ಯಾವುದೋ ಒಂದು atom this in general symbol adare. Is this clear? So it is in general symbol of an atom, and both atomic number and mass number will be right at left to this atom. Is this clear? Is there any doubts? Please clarify this thing. Both atomic number and mass number will be written left to the atomic symbol. ಈ ಅಟಾಮಿಕ್ ಸಿಂಬಲ್ ದ ಲೆಫ್ಟ್ಗೆ ನಾವು ಅಟಾಮಿಕ್ ನಂಬರ್ ಮತ್ತು ಅಟಾಮಿಕ್ ಮಾಸ್ ನಂಬರ್ನ ಬರಿಬೇಕು. ಅಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್, ಹಿಯರ್ Z ಈಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್ and A is atomic mass number. So Z is written as a subscript to the atomic symbol. Always this atomic number will be written as subscript to the atomic symbol, and atomic mass number is written as superscript to the atomic symbol. That means this A is written as superscript to the atomic symbol. Is this clear? That means at left and bottom corner of the atomic symbol is represented by atomic number, and at left and top corner will be represented by, or will be written by, atomic mass number. So in this way we have to In this way, we have to represent atom with atomic number and atomic mass number. Some of the examples are given here. So first of all, nitrogen is given. The atomic symbol for nitrogen is N, and here 7 is written, 7 and 14 both are written left to the atomic symbol, that is left to the N, and in subscript there will be 7, that means atomic number is 7. In superscript there will be 14, that means the atomic mass number will be 14. So another example is given, that is helium. Helium 24. Helium, He, is an atomic symbol of helium, and here 2 is atomic 2 is written at subscript to the atomic symbol, that means it will be atomic number, and 4 is superscript to the atomic symbol, then that will be the atomic mass number. That means here it is given that Z is equal to 2 and A is equal to 4. Z is atomic number, that is equal to 2, and A is atomic mass number, that is equal to 4. So now one more example is given here, that is uranium 92 to 38. So uranium, U is the atomic symbol of uranium, and subscript to this symbol there will be 92, that means atomic number is 92, and superscript to the atomic symbol, that there will be 238, that means atomic mass number will be 238. So this is in second note, they are clearly mentioned how to write an atom with atomic number and mass number. So this is clear. So here once again I will repeat the atomic symbol. Here they have taken X. X is in general atomic symbol. Remember it, it is in general atomic symbol. Both atomic number and mass number will be written left to the atomic symbol. ಎರಡು ಮಾಸ್ ನಂಬರು ಮತ್ತು ಅಟಾಮಿಕ್ ಮಾಸ್ ನಂಬರು ಮತ್ತು ಅಟಾಮಿಕ್ ನಂಬರ್ ಎರಡೂ ಕೂಡ ಅಟಾಮಿಕ್ ಸಿಂಬಾಲ್ ಲೆಫ್ಟಿಗೆ ಬರೀಬೇಕು. ಒನ್ ಮೋರ್ ಥಿಂಗ್ ಈಸ್ ದ ಅಟಾಮಿಕ್ ಮಾಸ್ ನಂಬರ್ ವಿಲ್ ಬಿ ರಿಟರ್ನ್ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಟು ದ ಅಟಾಮಿಕ್ ಸಿಂಬಾಲ್, ಅಂಡ್ ಅಟಾಮಿಕ್ ಮಾಸ್ ನಂಬರ್ ವಿಲ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ superscript to the atomic symbol. So that is X. In subscript they have written Z, and in superscript they have written A. So in this way we have to represent atom with atomic number and atomic mass number. So this is how to represent atom with atomic number and atomic mass number. So next they have given some of the definitions. The first one, here it is the third point, that is what is meant by isotopes. What is meant by isotopes? That means all the atoms, they didn't have the same atomic number, same number of nucleons. The number of nucleons are different for different atoms, right? So they are, but there will be some similarities. Look at here. First one is isotopes. The nuclei with same atomic number but different mass number are called isotopes. So different nuclei, if they have same atomic number, all the nuclei with same atomic number, but their atomic mass number is different, so such a nuclei are known as isotopes. For example is given here. So if you look towards here, carbon 612, carbon 613, here it is carbon 612, carbon 613, and carbon 614. If you look all these three nuclei, the atomic number is same, that means 666. But if you look at atomic mass number, that means superscript to the atomic symbol. So one is carbon 612, there will be 12. Another one is carbon 613, there will be 13. Another one is carbon 614, there will be 14. That means all these three nuclei have same atomic number but different mass number. Then these three are known as the isotopes of carbon. That means carbon isotopes. All these three are carbon atoms only, but with different mass number. So such a nuclei are known as isotopes. Is this clear? I think is this clear? The nuclei with same atomic number but different mass number are called as isotopes. Here carbon 612, carbon 613, carbon 614, these three are the isotopes of carbon. So one more example is given here, hydrogen 1 2, hydrogen 1 hydrogen 1 1, hydrogen 1 2. So here in one, hydrogen has atomic number 1 but mass number is also 1. In second, the second hydrogen has atomic number 1 and mass number is 2. That means both these two have same atomic number but different mass number. So these two are the isotopes of hydrogen. I think is this clear? I think now you are, I think I think you have clear idea about, you just got a clear idea about isotopes. Now the fourth point, that is isobars. So what are isobars? The definition is given here: the nuclei with same mass number but different atomic number are called isotopes. Here it is reverse of isotopes. That means these nuclei have same mass number but a different atomic number. Mass number is same but atomic number is different. So such a nuclei are known as isobars. Isotopes means same atomic number but different mass number. Isobars means same mass number but different atomic number. Here some of the examples are given. That means here it is, some of the examples are given. One is calcium, that is Ca, that is atomic symbol for calcium is Ca, and subscript they have written 20 and at superscript they have written 40. Another one is argon. Argon in subscript they have written 18 and in superscript they have written 40. That means here 20 and 18 are atomic numbers and superscript 40, in both the atom have same mass number, that is 40. Those are nothing but atomic mass numbers. That means these two, calcium 2040 and argon 1840, both have the same atomic mass number but a different atomic number. Therefore these two nuclei are known as isobars. So now coming to the point here, that is hydrogen 1,3, and one more thing is here, sorry, it is helium 2,3. It is not He23. It is not only H, but it is He23 because the atomic number is 2 here. That's why it will be He. So remember, correct it. Hydrogen 1,3 and helium He23. So both have the same mass number but a different atomic number. Then these two are also known as isobars. The nuclei with the same mass number but a different atomic number are called isobars. So next, fifth one is isotones. What are isotones? The nuclei having, so look at here, fifth one, isotones. The nuclei having same number of neutrons are called isotones. The same number of neutrons, that means the number of neutrons are same for both the atoms. For example, here example is given. Look at here, carbon 614. Here 6 is atomic number, 14 is atomic mass number. One more is nitrogen 715. Here 7 is atomic number and 15 is atomic mass number. So if we calculate the number of neutrons for carbon 614, that means 14 minus 6, that could be 14 minus 6, that could be equal to 8, right? So 14 minus 6, that could be equal to 8. That means the number of neutrons present in carbon 614 atom, those are 8, right? So next, the number of atoms number of neutrons present in nitrogen 715, that is 15 minus 7, that must be equal to 8. That could be equal to 8. That means both the nuclei have same number of neutrons, that is equal to 8. Then these two nuclei are known as isotones. Next, sixth one, isomers. The nuclei with the same atomic number and mass number but different energy state is known as isomers. So that means two nuclei have same atomic number, same mass number but a different energy state. That means one atom is at excited state. That means here they have given here carbon 612, the star is written, that means this atom is at excited state, and the carbon 612, the normally here there is no star, means it will be at ground state. That means both the atoms have same atomic number, same mass number, but the energy states are different for both the atoms. So you will clarify what are the energy states, what are the energy levels in atom chapter, not to worry about it. So here both the atoms have same atomic number, same mass number, but with different energy states are known as isomers. So next one is mirror nuclei. So what are mirror nuclei? Now look at here, mirror nuclei. Two nuclei having the same mass number with proton number and neutron number interchanged are mirror nuclei. That means here two nuclei are there, so their mass numbers are same, but the number of protons and number of neutrons are interchanged. That means atomic number and number of neutrons are interchanged. So such a nuclei are known as mirror nuclei. For example, lithium 37, beryllium 47, both have the same mass number, that is 44, but lithium atomic number is 3 and beryllium atomic number is 4. And for lithium the number of protons are 4, the number of neutrons are 4, and for beryllium the number of neutrons are 3. That means the number of protons and the number of neutrons are interchanged in these two cases for lithium and beryllium. So such a nuclei are known as mirror nuclei. Such a nuclei are known as mirror nuclei. So once again we will look towards, we will revise all these definitions. Isotopes, the nuclei with the same atomic number but different mass number are called isotopes. Isobars, the nuclei with the same mass number but different atomic number are called isobars. Isotones, the nuclei having same atomic number, same number of neutrons are called isotones. Isomer, the nuclei with same atomic number and mass number but different energy state is known as isomers. Mirror nuclei, the nuclei having the same mass number with proton number and neutron number interchanged are called mirror nuclei. So these are very important definitions. Please remember it. Please remember it. So one more important part today I am going to discuss, that is the definition of atomic mass unit. So we know that atomic mass unit is the unit of mass used to measure the mass of atomic and subatomic particles. Right. So the definition of atomic mass unit is given here, that is 1 AMU. That means one atomic mass unit is defined as the 1/12th mass of the natural carbon-12 isotopes. My natural carbon-12 isotopes, that means 1/12 into 1/12 into the mass of carbon-12 isotopes, that will gives you the 1 AMU. Therefore that 1 AMU is given here, that is 1.66 into 10 to the power minus 27 kg. That is the one value of 1 AMU. So simply 1 AMU is defined as 1/12th the mass of natural carbon-12 isotope, and that is equal to, that is 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. I hope you guys are understand. So further in next class we are going to study the general properties of nuclei. Thank you very much.